Hello guys, so we are back again yet in a new video, and in this session we are going to move one step forward in homogeneous function and come to the means you can say to the next part, which is Euler's theorem, and we will derive some equations, okay, some set of rules of Euler's, which they called Euler's theorem, in which is a part of partial differentiation. But before starting with the video, hope you have subscribed the channel so that we can bring more content to you guys, and don't forget to share it with your friends. Now let's begin with the lecture. So we in the last session, okay, before starting with the theorem, let me revise what we learned in the last session. In the last session we learned how to prove that the given function is a homogeneous function, right? HF. Second thing which we learned, that if there is a homogeneous equation f of x comma y, then we can write that f of x of degree n equals to 4. Then we can write that f of x comma y as x power 4 f of x by y, or y by 4 f of what you can say y by x. These two things which we learned. For this to happen, the function should be homogeneous. Now we have done with these two things. Now let's begin with the derivation of Euler's theorem. Okay, so derivation of Euler, for derivation we will we will consider a standard function. Let's say there is a function which is homogeneous. Okay, homogeneous. Let's consider a function like f of y by x. Sorry, it will be y by x. It will be x by y. Okay, just opposite. So here we have considered, and here we say here it is a homogeneous function. It is a homogeneous function, we are saying from the starting only. Now the proof which we are going to prove, okay, the proof Euler's theorem says nothing but it says if a function is homogeneous, then x into dou u by dou x plus y into dou u by dou y is nothing but n times u, the function itself, where n is degree of the function. Now we have to prove this. For this, you can see we require dou u by dou x and dou u by dou y, and multiply dou u by dou x by x and dou u by dou y by y to get the required proof. So let's do it. Partially differentiate u with respect to x. So what we are going to do, dou u by dou x, n x power n minus 1, f of y by x will become what? F dash y by x. And by chain rule, if I differentiate, what I am going to get, it is nothing but minus y by x square. Okay, now we got dou u by dou x. Similarly partially differentiate u with respect to y. We are going to get dou u by dou y, which will be we are not going to differentiate this because we are partially differentiating with respect to y. We are not differentiating with respect to x. So we will leave the x, and this will again become f dash y by x, and here it will be 1 by x. Okay, now let's substitute the things in LHS. It will be x into n x power n minus 1 f dash y by x minus y by x square. right? And if you observe, here we have y into dou u by dou y, which is x power n f dash y by x 1 by x. If we multiply x inside, I am going to get n into x power n f dash y by x into minus y by x square. And here we are going to get y by x, x power n f dash y by x, sorry, okay, we are done with this thing. Now what we are going to do, if you observe, minus y by x dou u by dou x minus y by x, okay, I think we have done a mistake or what, or we did some silly mistake. Okay, we differentiated it, we partially differentiated it, and then okay, here product rule will be applied and we will not directly differentiate it. Okay, this dou u by dou x partial differentiation has, okay, I should have applied chain rule because they both are different function. Okay, so I should have went for UV rule, but instead of going for UV rule, I just used chain rule, okay, which was my mistake. So let me get dou u by dou x correctly. Dou u by dou x is what, if I differentiate, I am going to get n x power n minus 1 f of y by x. Firstly, I am differentiating this. In the second time, what I am going to do is x power n, keep it as it is, and here f dash y by x into minus y by x square. So we got dou u by dou x. Now let's substitute here. If I substitute, what I am going to get in LHS, now this time, and here dou y by, in case of dou u by dou y, here there was x, so no UV rule will be applied. So this was wrong. Okay, I am cancelling out. Now let's substitute the values. X into n x power n minus 1 f of y by x plus x power n f dash y by x into minus y by x square plus y into x power n f dash y by x into 1 by x. If I multiply inside, I am going to get n x power n f of y by x, right? And here I am going to get minus, when x is multiplied, here it will be x power n minus 2 minus x power n minus 2 into f dash y by x, and here y will be as it is, minus y. Similarly, here what I am going to see is, here it would be, when y will be multiplied, it will be like minus y x power n minus 1 f dash y by x. We are doing any mistake? If I multiply, here also x will be multiplied, and this will be x, and this will be x minus 1. So these two will cancel out, and we are getting n x power n f of y by x. So this is the proof. So we are getting what, n into, and this x power n f of y by x is nothing but u, so we can call it nu. So from this, the formula x dou u by dou x, y dou u by dou y has been derived from here, which is n times u. Okay, so the formula is derived from here. Hope you have understand this formula, which is Euler's theorem, which they called. How we derived it? First we got dou u by dou x, and then we went for dou u by dou y, then we multiplied it by x, and then it multiplied by y. When we opened it, we got these two terms got cancelled out. Okay, and then we got our answer. Now what we are going to do, we are going to derive the second formula of Euler's theorem, which is the modification of the first one. Let me tell you the second formula, which they will tell you x squared dou square u by dou x square plus 2xy dou square u by, firstly it will be dou y dou x, okay, but you know dou square u by dou y dou x is equals to dou square u by dou x dou y, plus y square dou square u by dou y square, which is the property of, okay, partial differentiation. You should know this property, okay, it doesn't matter, equals to n into n minus 1 times y. N minus time u. Okay, if you take u, it will be u. If you take any other function y, it will be y. Now we have to derive this formula. Derivation is not that much important. You should know the formula. If you remember the formula, you will get your answer correctly. Now, by first Euler theorem, which I derive in the first, I know x dou u by dou x plus y dou u by dou y equals to n times u. I know this. If I partially differentiate this, differentiate 1 with respect to x, we get, what we are going to get, x dou square u by dou x square, okay, then dou u by dou x, UV rule, y dou square u by dou x dou y, right, and n times dou u by dou x. This is what our second equation. Now what we are going to do, similarly partially differentiate 1 with respect to y, we are going to get x dou square u by dou y dou x plus y dou square u by dou y square, second dou u by dou y, and lastly n times dou u by dou y. Now if I modify this, okay, we can modify both of them by bringing it here. Let's call it 3. Now what we should do, we will add, okay, but if we observe the proof which we wanted, okay, let me get the page. If you observe the proof which I just told you, here if you can observe, there is x square and here we have x only, and similarly here you can observe there is y square also, and here we have y term only in both of them. So what we are going to do, we are going to multiply here by x, then we will have x square in dou square u by dou x square, and similarly here we are going to multiply by y, so that we could have y square with dou square u by dou x square. So multiply x, multiply throughout by x into and by y in 3. If I do that, what I am going to get, x square dou square u by dou x square, x dou u by dou x, y dou square u by dou x dou y, x and dou u by dou x. If I take this dou u by dou x this side, I am going to get a modified dou square u by dou x square plus y x dou square u by dou x dou y. Here I am going to have x n minus 1 dou u by dou x. Call it fourth. And if I similarly, if I multiply this by y, I am going to have xy dou square u by dou y dou x plus y square dou square u by dou y square plus y dou u by dou y equals to n times y dou u by dou y. Now I am going to arrange the terms. So if I arrange the term, y square dou square u by dou y square, xy dou square u by dou y dou x plus, here if I move this that side, I am going to have y n minus 1 into dou u by dou y, right? if we simplify it further, not okay, just keep it here only. Let's call it 5. Add 4 and 5. What we are going to get? X square dou square u by dou x square, y square dou square u by dou y square, plus xy dou square u by dou y dou x, xy dou square u by dou x dou y equals to, here what I am going to have, n minus 1 will come outside. I will be left with, what we will be left with? We will be left with x dou u by dou x plus y dou u by dou y, if you add them. Now you know x dou u by dou x is nothing but n times u, so I am going to substitute n into n minus 1 into u. And here if you observe, I have told you just one property of partial differentiation, that dou square u by dou x dou y is equals to dou square u by dou y dou x. So no matter what you write in the theorem, the teacher will give you marks. Okay, the teacher will give you, because they both are same only as per the partial differentiation rule. So this formula will finally get simplified and we will get the final equation, this thing. You can write it whatever you like, n minus 1, this thing, dou x dou y or dou y dou x as per your requirement. So this is our final second theorem of which comes in Euler section. So both the theorem you should learn. The derivation is not important. The second derivation was a little bit important because you come to know this property, although when we were solving partial differentiation second order and third or higher order derivative, we came across this situation also. But if you have forgotten, then it will get revised or brushed up as you, whatever you think. Now let's take some questions on this. The first question which we are going to take is this question. The page is little torn up, sorry for that. Now the question says, if u equals to e power x by y sin x by y, sin into x by y plus e power x by y cos y by x, prove that x dou u by dou x plus y dou u by dou y. Now here you can directly observe that this is nothing but the proof which we derived just now. But do we need to prove all the things again? No. What we have to prove in the theorem, I told you in the starting that what we considered that the function should be homogeneous. Now if it is homogeneous, then I don't need to derive the whole thing. I can directly say it will be this thing, which is the homogeneous equation condition, that x dou u by dou x plus y dou u by dou y equals to 0. Now what my job is, first write this equation, x by y. Let the teacher know, represent everything properly, then only you will get complete marks. After writing this step, what you will mention, put x is equals to lambda x and y equals to lambda y. Where in 1? The moment you do this, you will write u of x comma y equals to e power lambda x by lambda y into sin lambda x by lambda y plus e power lambda x by lambda y into cos lambda y by lambda x, which will if you can clearly see that this lambda will cancel out, and you are finally getting what, lambda power 0 e power x by y into sin x by y e power x by y into cos y by x. So this is nothing but lambda times u of x comma y only, and this is what, lambda x comma lambda y. So what you have to write, this statement is very important. So u is I am writing HF, homogeneous function of degree, what degree? 0 in variable, in what variables? In variables x comma y. This statement, this part is very crucial. If you don't write that statement, the teacher will deduct the marks, but this statement is additional, it's up to you. After this, what you have to do, since it is a variable, I can apply x dou u by dou x plus y dou u by dou y is equals to what? It was n times u, where n was what, degree, and here n is what? N is equals to 0. equals to 0 into u, it will be 0, and here you will mention since n equals to 0. And so we are done with this problem. Hope you have understand this problem properly. Now let's take the next question. So the next question which we are going to take is as follow. If u equals to 1 by x square plus 1 by xy plus log x minus log y, the whole upon x square plus y square, prove that x dou u by dou x plus y dou u by dou y plus 2y equals to 0. What we have to do, we have to write u again. That is the starting thing which you have to do. I can note down one thing, that x dou u by dou x and y dou u by dou y is nothing but my Euler's theorem proof. So for this to know this value, I should prove it that it should be what? It should be homogeneous function. So what I'm going to put, x equals to lambda x and y equals to lambda y in what? In 1. If the moment we do that, we will write lambda x comma lambda y equals to 1 by lambda square x square plus 1 by lambda square xy plus log, I can write it lambda x by lambda y, the whole by using the property. You have to mention here the property also, that log m minus log n is nothing but log, what is the property? Log m by n. Okay, you have to mention this property, otherwise your marks will be deducted. Lambda square x square plus y square. So here this thing will cancel out, and this lambda square will come outside. So finally we are coming across 1 by lambda square equals to 1 by x square plus 1 by xy plus log x by y by x square plus y square, right? So this is nothing but this u, so I can replace it by u. Now if I take lambda up to the numerator, it will become lambda power minus 2 into u. So what I will say, so u is a HF, homogeneous function of degree minus 2 in variable x comma y, and here while mentioning degree you can mention as it n equals to minus 2, so the teacher will have an idea that n value is minus 2. Now what you have to do, you have to apply. So by right here like this, by Euler's theorem, x dou u by dou x plus y dou u by dou y is nothing but n times u. We know n value is minus 2, so x dou u by dou x plus y dou u by dou y equals to minus 2u. If I take the minus to that side, I am going to left with x dou u by dou x plus y dou u by dou y plus 2u equals to 0. So this is our required proof which we wanted to prove. So we are done with this session. In the next session we are going to take some more questions on Euler's theorem based on these two theorems, and then we will see some more new forms of these two theorems only. Okay, till then revise these lectures, okay, and the previous also. See you in the next lecture. Thank you.